In the name of God. Hi everyone. My presentation is about the Swampland criteria in Technicolor inflationary model. So I describe some of the motivation for the idea and then I explain our work in detail. So, as it is now in the literature, a new idea has been put forward as a Swampland program to check theories coupled to gravity, to check the consistency of quantum gravity, and finally a proof for string theory. Recently, much work has been done in this field due to the special condition of string theory and the fact that its testing and experimental investigation seem a bit difficult. This idea has been proposed to test and investigate various concepts of cosmology. The Swampland program is challenged from two sides, from an up to bottom view for introducing principle and limitation to introduce conjecture, as well as mathematical formulation to examine cosmological concepts. A second look from the bottom up in order to test each of these conjectures with various concepts of cosmology, including inflation and matching with observable data, which is both a proof for his new idea and a proof for string theory. So far, many conjectures have been proposed from this theory, and now, according to the structure and further investigation, new conjecture will be added to this program. Some of these conjectures face challenge, and as a result, corrections are made to these conjectures. Everything is limiting in quantum gravity, as in few out of every state is worked by the laws of quantum field. At this point, when gravity is considered and the quantum level, the theory will be incompatible. The objective of the Swampland program is to decide the limitation that an effective field theory should satisfy to be viable with the consideration of UV in quantum gravity. They are Swampland criteria, and different suggestions are figured out regarding Swampland conjecture. The objective is recognize this limitation and prove whether to accept or refuse them inside the structure of quantum gravity. Of course, the Swampland idea isn't restricted to string theory. On a fundamental level, Swampland conjecture are frequently examined by string theory. Without a doubt, the string theory gives an ideal structure to through quantitative testing of conjectures and work on how we may consider the potential compactification of string theory. So, we can examine the inflation model using De Sitter and refine De Sitter conjecture where C1 and C2 are in the order of 1. By combining two De Sitter and refined De Sitter conjecture, the researcher obtained a new conjecture called the further refining De Sitter Swampland conjecture, as you can see in PowerPoint, which solves the contradiction between the Swampland De Sitter conjecture and single field slow rule inflation. The other conjecture is the weak gravity conjecture, is one of the conjecture of Swampland program, which considering gravity is the weakest force. Also, Paletti generalized this conjecture so that gravity is even weaker than the force of a scalar field, and this is called the scalar weak gravity conjecture, or SWGC. We also have the strong version of SWGC, or strong scalar weak gravity conjecture. So we examine the specific of composite inflation, such as the Technicolor inflation model, with the mentioned conjecture such as scalar weak gravity conjecture, scalar strong weak gravity conjecture, and further refining Swampland De Sitter conjecture. We found that this model is inconsistent with the De Sitter and refined De Sitter conjecture, so their conditions were unsatisfied. Then we challenged the model with other conjecture, and we found the model will be consistent with the further refining Swampland De Sitter conjecture by adjusting its free parameters such as Q, A, and B. Also, we found that this model will not be compatible in all phi values for two conjectures with SWGC and SSWGC. According to figure 1 and 2, for two conjectures, when phi is smaller equal 0 than 45, and the specific interval for phi with strong scalar with gravity conjecture specify this conjecture will be satisfied for mentioned inflation model. So we conclude the mentioned model violate 2 and satisfy 3 conjecture with a special interval for phi of the Swampland program, and it is a suitable model for investigation of the universe evolutions. Thank you for your attention.